AWS Security. Understanding AWS IAM. 1. Introduction to AWS IAM. AWS Identity and Access Management, IAM, is a web service for securely controlling access to AWS resources. 2. Key components. IAM includes components such as users, groups, roles, and policies to manage permissions. 3. User management. IAM allows creation and management of AWS users and their access permissions. 4. IAM policies. These are documents defining permissions and can be attached to users, groups, or roles. 5. Roles and permissions. IAM roles provide a way to delegate permissions to entities, users, applications, without sharing security credentials. 6. Security best practices. Includes enforcing strong password policies, using multi-factor authentication, MFA, and regularly auditing IAM permissions. Advanced features of AWS IAM. 1. Conditional access control. IAM policies can include conditions for user access, such as time or IP constraints. 2. Integration with other AWS services. IAM seamlessly integrates with other AWS services for managing access. 3. IAM role for cross-account access. This feature allows users from one AWS account to access resources in another. 4. Identity federation. Supports identity federation to enable external users to access AWS resources without needing to create IAM users. 5. Access Advisor tool. Helps in understanding service permissions and how they are being used, assisting in security optimization. 6. IAM Access Analyzer. Analyzes resource policies to identify any unintended access granted outside of the AWS account. AWS IAM, users, groups, roles, and policies. 1. Overview of AWS IAM. AWS Identity and Access Management, IAM, is a web service that helps you securely control access to AWS resources for your users. It enables you to manage users, security credentials such as access keys, and permissions that control which AWS resources users and applications can access. 2. IAM Users. An IAM user is an entity that you create in AWS to represent the person or application that uses it to interact with AWS. A user in IAM is not the same as a person. It can also be an application that needs to make API calls to AWS. 3. IAM Groups. An IAM group is a collection of IAM users. You can use groups to specify permissions for a collection of users, which can make those permissions easier to manage for those users. 4. IAM Roles. IAM roles are a way to delegate access with defined permissions to trusted entities without sharing access keys. Roles can be assumed by anyone who needs them, including IAM users from the same AWS account, different accounts, or even by AWS services themselves. 5. IAM Policies. IAM policies define permissions and can be attached to users, groups, or roles. These policies control what actions are allowed or denied on different AWS resources. 6. Best practices in IAM management include least privilege access, regular audits of IAM settings, use of multi-factor authentication, and rotation of credentials. Introduction to AWS KMS. 1. AWS KMS Overview. AWS Key Management Service, KMS, is a managed service that enables the creation and control of encryption keys used to encrypt data. 2. Key concepts. Involves master keys, cryptographic algorithms, key rotation, and key policies. 3. Key management. Allows creation, rotation, and deletion of keys, also monitors their use. 4. Encryption and decryption. KMS provides APIs for encrypting and decrypting data up to 4 kilobytes in size. 5. Integration with AWS services. KMS is integrated with other AWS services like S3 and EBS, enabling encryption of stored data. 6. Compliance and security. Complies with various certifications and offers tools for audit and compliance tracking. Advanced features of AWS KMS. 1. Customer managed keys. Users can create and manage their own encryption keys. 2. Automated key rotation. Automatically rotates keys to enhance security. 3. Cloud HSM integration. Offers integration with AWS Cloud HSM for hardware-based key storage. 4. Cryptographic details. Supports various cryptographic algorithms and standards. 5. Access control and policies. Fine-grained access control and policies can be applied to keys. 6. Logging and monitoring. KMS integrates with AWS CloudTrail for logging and monitoring of key usage. Introduction to AWS Secrets Manager. 1. Overview of AWS Secrets Manager, a service to manage, retrieve, and store sensitive information like database credentials, API keys, and other secrets. 2. Key features include centralized management, secret rotation, and secure access to sensitive information. 3. Secret rotation enables automatic rotation of secrets without disrupting the application. 4. Secure storage and retrieval, secrets are encrypted and can be accessed securely using IAM roles and policies. 5. Access control, fine-grained access control for managing who can access specific secrets. 6. Integration with AWS services, seamlessly integrates with other AWS services for enhanced security and management. Best practices in AWS Secrets Manager. 1. Implementing secret rotation, regularly rotate secrets to reduce the risk of unauthorized access. 2. Enforcing IAM policies, use IAM policies to control who can manage or use the secrets. 3. Logging and monitoring, utilize AWS CloudTrail for logging access to secrets for security and compliance. 4. Using resource-based policies, apply resource-based policies directly to secrets for more granular access control. 5. Cross-account access management, securely manage secrets across different AWS accounts. 6. Automating secret creation, automate the creation of secrets to reduce manual errors and increase efficiency. Understanding S3 encryption. 1. Basics of S3 encryption. Encryption in Amazon S3 is about protecting data at rest and in transit. S3 offers multiple methods to encrypt data. 2. Server-side encryption, SSE. Data is encrypted automatically when saved to S3 and decrypted when downloaded. 3 types, SSE S3, SSE KMS, and SSEC. 3. Client-side encryption. Data is encrypted on the client side before being uploaded to S3. Upon retrieval, it is decrypted by the client. 4. Key management options. Keys for encryption can be managed through AWS KMS, client-side master keys, or S3 managed keys. 5. Encryption in transit. S3 uses HTTPS to encrypt data in transit, ensuring secure data transfer. 6. Best practices for S3 encryption include using HTTPS, regularly rotating encryption keys, and implementing access control policies for data security. Advanced encryption features in S3. 1. S3 Object Encryption enables encryption at the object level for finer control. 2. Multi-factor authentication, MFA, delete, adds an additional layer of security for deleting objects. 3. Bucket policies and encryption, use bucket policies to enforce encryption on all objects stored in the bucket. 4. Integration with AWS CloudTrail, tracks and logs all encryption and decryption operations for auditing purposes. 5. Compliance and standards. S3 encryption helps in meeting various compliance requirements like HIPAA, GDPR, etc. 6. Automated encryption tools. Tools like AWS Lambda can be used to automate the encryption of newly uploaded files. Understanding AWS STS and cross-account access. 1. Overview of AWS STS. AWS Security Token Service, STS, enables the creation of temporary, limited privilege credentials for AWS Identity and Access Management, IAM, users or for users authenticated by a mobile or web application. 2. Key features of STS, temporary credentials, customizable permissions, and active federation with external identities. 3. Cross-account access basics, allows IAM users to access resources in a different AWS account. 4. Role-based access control, involves creating roles in one AWS account that users from other accounts can assume. 5. Security Token Service, STS, API operations, includes assume role with web identity, and get session token for generating temporary credentials. 6. Best practices for STS and cross-account access, regularly review and update cross-account permissions, monitor role activity, and enforce least privilege principle. Advanced concepts in STS and cross-account access. 1. Trust relationships, establish trust between accounts by defining which accounts can assume roles. 2. Conditional policies in STS, use conditions in STS policies to further refine access and permissions. 3. Cross-account role assumption, techniques for efficiently assuming roles across different AWS accounts. 4. Session duration management, managing the duration for which the temporary credentials remain valid. 5. Auditing and compliance. Utilize AWS CloudTrail and IAM Access Analyzer for auditing cross-account access. 6. Integrating with external identity providers. Using STS to enable identity federation with providers like Active Directory, SAML 2.0, and OpenID Connect. Understanding identity federation in AWS. 1. Concept of identity federation. Identity federation in AWS refers to the practice of using external identity providers to grant access to AWS resources, eliminating the need for separate IAM user accounts. 2. Federation with external identity providers. This involves linking AWS with identity providers like Microsoft Active Directory, LDAP, or Google Apps. 3. AWS IAM roles for federated users. Federated users are granted temporary access to resources by assuming specific IAM roles. 4. SAML 2.0 integration. AWS supports Security Assertion Markup Language, SAML, 2.0 for federating users of a corporate directory with AWS resources. 5. OpenID Connect and Federation. OpenID Connect is another protocol used for identity federation, allowing authentication with web-based identity providers like Google and Facebook. 6. Federation use cases. Common scenarios include providing single sign-on, SSO, to AWS Management Console and accessing AWS resources from corporate applications. Best practices in security and identity federation. 1. Implementing least privilege principle. Ensure federated users have only the minimum necessary permissions. 2. Regular auditing of federated access. Routinely check and update federation arrangements and permissions. 3. Secure Token Service, STS. Best practices. Use STS for temporary access and minimize security risks. 4. Identity provider security. Keep the identity provider configurations secure and up to date. 5. Managing federated user permissions. Use IAM roles and policies effectively to manage federated user permissions. 6. Monitoring and logging federation activity. Utilize AWS CloudTrail and other monitoring tools to track federated user activities for security and compliance. Introduction to AWS CloudTrail. 1. Overview of CloudTrail. AWS CloudTrail is a service that provides a record of actions taken by a user, role, or an AWS service in AWS, enabling governance, compliance, operational auditing, and risk auditing. 2. Key features: continuous monitoring, detailed event logging, and the ability to define specific log data retention periods. 3. Event logging in CloudTrail, tracks and logs API calls and related events across AWS infrastructure. 4. CloudTrail log file integrity, ensures the integrity of log files by validating the logs haven't been tampered with. 5. Integration with other services. CloudTrail integrates with services like Amazon S3, AWS Lambda, and Amazon CloudWatch for enhanced monitoring and alerting. 6. Security and compliance, essential for meeting regulatory compliance requirements and enhancing the security posture of an AWS environment. Advanced CloudTrail features and management. 1. Multi-region monitoring, ability to track and log events across multiple AWS regions. 2. Customizable data event logging, customizable logging options for specific resources or activities. 3. CloudTrail Insights, identifies unusual activity in your AWS accounts by analyzing normal API usage patterns. 4. Trail organization and management, organize and manage trails for better administration and oversight. 5. Log file encryption and protection, encrypt log files using AWS Key Management Service, KMS, for added security. 6. Best practices in CloudTrail usage, regularly review and audit CloudTrail logs, integrate with monitoring tools, and maintain strict control over access to log data. Understanding AWS VPC endpoints. 1. Introduction to VPC endpoints. VPC endpoints allow private connections between your Amazon Virtual Private Cloud, VPC, and AWS services without requiring an Internet Gateway, NAT device, VPN connection, or AWS Direct Connect connection. 2. Types of VPC endpoints. There are two types: interface endpoints, powered by AWS Private Link, and gateway endpoints, currently available for Amazon S3 and DynamoDB. 3. Use cases for VPC endpoints, ideal for secure and private communication between AWS services, reducing the need to expose data to the public internet. 4. Security and access control. VPC endpoints can be secured using VPC endpoint policies and NACLs, network access control lists, to control traffic. 5. Performance and cost efficiency. Improves performance as traffic uses the AWS network, which is often more cost efficient than public internet routing. 6. Limitations and considerations. It's important to understand the limitations, like supported services and regions, and integration with other AWS services. Advanced topics in AWS VPC endpoints. 1. VPC endpoint services. AWS Private Link provides the ability to expose your own services within your VPC to other AWS accounts. 2. DNS considerations. Managing DNS resolution for endpoint services to ensure seamless network connectivity. 3. Monitoring and logging. Utilizing CloudWatch and VPC flow logs for monitoring and logging VPC endpoint activity. 4. High availability and redundancy. Setting up VPC endpoints in a highly available and redundant manner across multiple availability zones. 5. Integrating with IAM. Using IAM policies to manage permissions and control access to VPC endpoints. 6. Best practices in VPC endpoint configuration. Recommendations include using endpoint policies for fine-grained control and considering the impact on network design and architecture. Thanks for watching.